A warm welcome, dear friends of protection, control and electrical engineering. This year, the new WIC1 from SEG Electronics is faster than your airbag. We are skeptical and will check it out today. Let's get started, relax and enjoy the melody. The new WIC1 is black start capable and faster than your airbag, says the announcement for the new second generation WIC1. This statement refers to the switch onto fault time. The switch onto fault time is about what happens when an electrical system will be powered on and there is already an existing electrical short circuit before the switch on process. The classic here is a forgotten temporary grounding or an illegal closed grounding switch, which is socially acceptable thanks to interlocking concepts of drunken morons. For a protection relay supplied with an external auxiliary voltage, this fault is usually not a big deal. A fast trip is possible due to the fact that our device is already powered up and under constant attention. However, it always becomes problematic when we enter the world of current transformer powered protection relays. A protection relay which is supplied with energy coming from the CTs is not able to trip immediately because the CT powered relays are forced to boot first. You all know this from your lovely Windows computers. And only now, after this wake-up process, is the relay able to make the protection decision and to trigger a possible reaction. And this is exactly where the hamster starts to limp. The faster a CT-powered relay boots, the faster it can react to a switch onto fault event. And now imagine that there are CT-powered protection relays on the market that come along with startup times in the double-digit second range. In this case, you can forget about the protection system and just call the fire department in case of fire. The second generation WIC1 now claims to complete the entire boot process within a mains period. That is just about 70 milliseconds in the 60 Hz network. A classic steering wheel airbag needs at least 50 milliseconds including ignition and inflation. So let's have a look again to the trailer.
The new WIC1. Faster than your airbag.
We protection engineers are skeptical by nature and need to see things with our own eyes. For this reason, we have prepared the test setup shown here. We see our Compano 100 test set, which is used to drive a test current through all three current transformers. Please note that we wrapped the measuring cables 4 times around the CTs in order to avoid the test cables drip off the table. Sure, we can of course also use the test sockets on the front of the WIC1, but we want to get as close as possible to the conditions in practice and have decided to use a primary current injection. The trip signal of the WIC1 will be triggered via binary input 1 of the Compano, and we can also see the new DigiMac, which is connected to the WIC1 via Ethernet cable. Let's look at the settings. Our system configuration has a nominal current of 36 amps and we have parameterized a simple definite time value to 1.5 times of the nominal current, which corresponds to a setting value of 54 amps. As part of our test, we are now interested in the tripping time difference between a short circuit of a relay that is already booted up on the one hand and a short circuit of a relay that is previously in de-energized condition. We want to test with particularly weak currents since this is the much harder case for the relay. Let's get started with a jump from the nominal current to twice of the nominal current, which means from 36 amps to 72 amps. Since we wrapped the CTs 4 times, we output a jump from 9 amps to 18 amps and measure the time. Okay, let's push the button. We measure a time of 27 milliseconds and now repeat the test with a jump from 0 amps to 72 amps or of course to 18 amps. You remember the 4-fold winding of the CTs. And get a time of 33.9 milliseconds. Standing ovations, ladies and gentlemen. The difference between these two release times is just 6.9 milliseconds. From my point of view, this is absolutely amazing because in our current example, the relay boots within less than half of a mains period. That's damn fast. Okay, let's take it to the extreme and repeat the measurement with an even smaller current. We now jump to 110% of the parameterized pickup volume. This is 54 amps and we are now testing with 59.4 amps or with the 4-fold winding current of 14.9 amps. We push the button again. Okay, and repeat this test for the second time, coming from 0 amps. And measure an amazing time difference of only 10.2 milliseconds and are ready for the shocking conclusion. Despite pretty small test currents, the WIC1 actually manages to boot easy within one mains period and is the outstanding king of its class. We will do a detailed product review of the WIC1 later, but one thing is already clear by now: the new WIC1 is faster than your airbag. Warm wishes and see you soon.